In this video, I'm going to solve an example finding a state equation, output equation for a given electrical circuit. In my previous videos, I had one input and one output, but here I have two inputs. One is a voltage source U1, another one is another current source U2, and output he's asking us to find voltage across this R3. So those are the input and output. So this is a multiple input single output system. So multiple inputs single output system, MISO. You might have seen single input single output system, multiple inputs single output system. Now, as we discussed before, always choose the state variable across energy storage element. So we always choose the voltage across capacitor. That's one of my state variable, and another state variable is current passing through the inductor. I always choose X as my state variable, but you can choose V1 as state variable and I2 as another state variable, and I3 or I2 as your another state variable. My apology, I always choose X1, X2, X3. That's easy, because even if it's a mechanical system, still we can use the X1, X2, X3. A system need not to be electrical system. It could be mechanical. It could be a system which exists on the paper. Still, this mathematical modeling will work. So our goal is writing the X1 dot equal to something, X2 dot equal to something, X3 dot equal to something. So what I'm going to do here, I have output. So this is a single node. So in this node, that's the voltage Y. We are going to take this as ground. So I can say my X1 simply equal to U1 minus Y. I always talk about this example. So here is VA, here is VB, so this is VAB. So VAB equal to VA minus VB. If you follow this methodology, you will end up with, so voltage here is U1, U1 minus Y must be equal to X1. So Y equal to, here Y equal to, if I bring the U1 to the other side, X1 minus U1. So Y equal to X1 minus U1. Here I do not see X1 dot or X2 dot, X3 dot or any other unknown variables. So I can say this is my output equation. Okay, so I have output equation. Now I need to write down the X1 dot, X2 dot, X3 dot. Now I'm going to use apply KVL in this loop. My apology, KVL. So U1 equal to X1 plus L1 X2 dot. Now I have equation for X2 dot. So X2 dot equal to, or L1 X2 dot equal to U1 minus X1. So X2 dot equal to 1 over L1 minus X1 plus 1 over L1 U1. This is X2 dot. So I found X2 dot. Now I'm going to write an equation KVL, or apply KVL in this loop. Okay. How did I come up with this idea? It's just with experience and with practice. So I'm going to take this. So I'm going to start with U1. U1 equal to X1 plus L2 X3 dot plus R2 X3. Excellent. So here I have X3 dot equal to something in terms of X1, X2, X3 plus U1 and U2. So I'm good. I can take this as state equation. Minus X1 minus R2 X3 plus U1. So X3 dot equal to minus 1 over L2 X1 minus R2 over L2 X3 plus 1 over L2 U1. This is another state equation. So all I need X1 dot. We'll find that in a second. Now I'm going to write the x1 dot. So to find the x1 dot, I have to take the current here, unknown current I1. So x1 dot equal to 1 over C I1. Now I1 is unknown. I need to convert that I1 into in terms of U1, X1, X2, X3 and U2. So I'm going to say I1 current is coming in, X2 is going out, X3 is also going out, and U2 is coming in, and I don't know this current, I2 is going out. So I can say I1, what I'm doing here, I'm applying KCL at this node. This node is nothing but all of this. This complete thing is called one node. So I1 plus U2 equal to X2 plus X3 plus I2. Now to replace I1, I have another unknown I2. I need to replace I2. That's simple. I can write I2 is nothing but y over R3, and I already defined y, which is x1 minus u1 over R3. So I can say I1 plus I1 equal to minus I1 equal to, I'm going to take u2 to the other side, and I'm going to replace I2 equal to this. So it's going to be x1 over R3, x1 over R3 plus x2 plus x3 minus u1 over R3 minus u2. This is my I1. So I'm going to substitute I1 in x1 dot. So x1 dot equal to 1 over C I1, right? So 1 over R3C x1 plus 1 over C x2 plus 1 over C x3 minus u1 over R3 times C minus 1 over C u2. That's my x1 dot. Now I'm going to write this in the matrix format. I have x1 dot, x2 dot, x3 dot. So we know that x dot is nothing but ax plus bu and y equal to cx plus du. This is a state equation. That's my output equation. So state equation tells us the instantaneous state of a system. So to get this A matrix, so all you need to do is write down the coefficients of x1, x2, x3. So for x1 I have 1 over R3C plus, that's one term, 1 over C, 1 over C. Do I have C1 here by any chance? Yeah, I labeled this as C1, but I used C, so do not get confused. It's there is only one capacitor, so we can take that as C for time being instead of C1. So that's my A matrix. X2 dot equal to minus 1 over L1 0 0, and x3 dot equal to minus 1 over L2 0 minus R2 over L2. That's my A matrix. And when it comes to the B matrix, you have u1 and u2 here, so minus 1 over R3C minus 1 over C. Here x2 dot, I have 1 over L1 0, there is no u2 term here, and here 1 over L2, so x3 dot, that's u1 and u2 equal to 0. And C term comes from the output equation, so C equal to 1 0 0, and D term is also, I have u1 here, so that's going to be minus 1. Looks like I made a mistake here. So if you look at this x1 equation, u1 minus y, right? So this must be minus x1 plus u. My apology. So this must be minus 1. So here u1 you have 1, there is no u2, that's going to be 0. That's the D matrix. I'll stop it here. Ask me if you have any questions. Thank you.